Every combustion reaction needs of three conditions: oxygen, fuel, and temperature. Gases such as carbon dioxide, nitrogen, and other exhaust gases produced in the combustion process are considered inert when they contain a percentage of oxygen lower than 10%. In fact, below this oxygen percentage, the combustion process cannot take place because there is not enough oxygen to feed it. One of serious problems on board crude oil tankers and chemical carriers is the danger of accidental fires and explosions. Hydrocarbon vapors given off by the crude oil and petroleum distillates carried in the cargo tanks can form an explosive mixture if they are mixed with atmospheric air containing on average 18% of oxygen. This air and vapor mixture can easily be set on fire in circumstances which are often both difficult to prevent. To prevent accident, the International Organization for Safety at Sea drew up a series of safety regulations and procedures which must be strictly followed. These safety procedures involve replacing the atmospheric air in cargo tanks with inert gas so as to prevent combustion from taking place. The inert gas introduced into the cargo tanks contains such a low percentage of oxygen so as to make combustion impossible. Inert gas generation systems are used on board many kinds of ships and in several industrial plants. They can be found in refineries for tank protection and for pipeline cleansing, and in the chemical and petrochemical industry. They are also found in the steel and aluminum furnaces, in the pharmaceutical industry, and in several food industries. Ships with inert gas generating plants are those which transport highly flammable cargoes, like oil tankers, gas and chemical carriers, and OBO ships, or ships carrying cargoes which tend to undergo oxidation, like chemicals and food. Gas carriers carry LPG, liquefied petroleum gas, LNG, liquefied natural gas, ammoniac, and ethylene, which are all highly volatile and inflammable substances. Oil tankers carry crude oil and its derived products. OBO ships carry bulk and solid minerals and petroleum products. Chemical carriers transport chemical products in a liquid state that can easily catch fire on contact with the air, and can set off the unwanted process of oxidation. Bulk carriers may also carry goods that can be oxidized and deteriorate on contact with the air. The percentage of oxygen contained in the inert gas product by this onboard system can vary from the 0.5% necessary for the chemical and gas carriers to the 5% of OBO ships and oil tankers. A liquid fuel, like diesel oil, is burned in a boiler with a controlled amount of air, so as to keep the oxygen contained in the resulting gases as low as possible. The resulting gases mainly contain carbon dioxide, nitrogen, and water vapor, and when diesel oil is used as the fuel, traces of nitric and sulfur oxides can also be found. The oxides are eliminated during the scrubbing process. First, the gases generated in the combustion process enter a scrubbing tower, where they are cooled and purified. In the tower, they pass under jets of seawater, which remove the nitrous and sulfur oxides. When they leave the tower, the gases pass through special demister filter, which absorb the water moisture. In the high-pressure inner gas plants, a compressor is included in the system which compresses the gases to the desired pressure. The dried gases are then sent under pressure to the cargo tanks through a series of pipelines. The oxygen analyzer continuously monitors the percentage of oxygen into the gas. The deck water seal located on the main deck prevents any backflow of gases into the engine room when the system isn't in operation. It is followed by no-return valves, which have the same function. When the inner gas system is in operation, the inner gas enters the seal under pressure through an inlet tube. It overcomes the resistance of seawater in the tank and rises the top of the seal, from where it continues its way to the cargo tanks. If the hydrocarbon vapor has more pressure than inner gas, seawater goes up to the inner gas inlet tube, preventing any hydrocarbon gases flow back. After the deck water seal and the no-return valve, there is the pressure vacuum breaker, which regulates the sudden raising or lowering of the pressure in the inner gas system. It consists of a cylinder that contains water. In the cylinder there is an inlet tube for the inner gas. When the gas pressure is too high, the water rises up the cylinder and forces the excess gases to escape into the atmosphere. When the pressure is too low, the water rises up the gas inlet tube, pushing up the gas, which flows to the tanks with a new pressure. Now the inner gas is ready to be sent in the tanks, where it prevents any accidental fire or explosion.